full screen. All right, so this is chapter 1, introduction to semiconductor. Okay, what do you understand with semiconductor?
So may I share?
Yeah, sure.
So semi means half. So semiconductor means the material is half conductor, meaning it contains the properties of both a conductor and an insulator, depending on how much the ratio we use to make the material.
Yes, very good. Thank you very much.
Welcome, sir.
Okay, okay. So that's basically that's right spot on. What is the meaning of semiconductor? If you look at the definition itself, you can actually interpret. Okay, semi means half or a portion of it. Conductor means conductivity, which conducts electrons or electricity and so on. Okay. All right. This is Bohr's model. Okay. So according to the Bohr's model, we have orbiting electrons and then we have nucleus in the center. Okay, so Bohr's model here, as you can see, here's a proton and neutron, and then electrons. Okay, protons basically particle of positive charge. Electrons is basically particle of negative charge. Okay, always in motion. Okay, electrons always in the move. Okay, neutrons is uncharged particles. Okay, so nucleus is the combination of both neutrons and protons at the center of the electron. Okay, so do we understand now? Now, this is just a review. This is what you have done in Form 4. So if you can see, protons and neutrons is at the center of the structure, and we call them nucleus. All right. So protons is positively charged, electrons is negatively charged. Okay, atoms and their shell, electron orbits the nucleus. Okay, orbit the nucleus of an atom at certain distances from the nucleus. Electrons near the nucleus have less energy than those in more distant orbits. Apa maksudnya? Electron near the nucleus has less energy. Maknanya kalau this is 2D punya ni nucleus. Okay, this is the orbit 1 and orbit 2. Okay, so electrons near the nucleus, let's say electrons, we have electrons here and in orbit 1 and electron in orbit 2. Okay, so electron in orbit 2 is further away from the nucleus. So what does it mean? Electrons near nucleus less energy than those in more distant orbit. Maknanya yang lagi jauh is having higher energy, alright, as compared to the one that is closer to the nucleus. Only discrete, separate and distinct values of electron energies exist within atomic structure. Apa maksud discrete? Tak dengar lah. Kuat sikit.
Berbeza.
Berbeza. Okay, boleh close to it. Discrete means separate and distinct, as is shown here. Values, maksudnya dia number of electrons tu dia ada discrete, maknanya 1, lepas tu 2, lepas tu 3. Dia tak ada 1.5 number of electrons, 1.3, tak ada. Dia ada 1, 2 atau 3. So discrete, round numbers. Therefore, okay, that's one thing. So therefore, electrons must orbit only at the discrete distances from the nucleus. Each discrete distance orbit from nucleus corresponds to a certain energy level. So orbit ni pun discrete, okay, orbit 1, orbit 2, dia tak boleh berada di tengah-tengah. Okay, for example, orbit 1, electron tak boleh berada kat sini, yang saya tanda pangkah ni. It cannot be there. It has to be either in orbit 1 or orbit 1 or orbit 2. Okay. in an atom, orbits are grouped into energy bands known as shells. Okay, so this is the orbit is the group into energy bands ataupun shells. Okay, number of electrons in each shell. Okay, so orbit ni now we call it shell. Okay, this is shell number 1 and shell number 2. Alright, what is the maximum number of electron dalam setiap shell? Inside on each shell. Okay, ini pun boleh tergeliat lidah cell dengan shell. Alright, maximum number of electrons that can exist in each shell of an atom. Okay, where the number of shell is this depends on this formula. Okay, number of electrons and E is 2 times n squared. So when n equals to 1 and number of shell is 2 times 1 squared, that becomes, so 1 squared is 1, so number of electrons will become 2. So here the maximum electron in this shell, you can have 2 electrons. Alright, and then n equals to 2. Okay, when n equals to 2, so the formula equals to 2. So number of shell is 2 times 2 squared equals to 8. Okay, 2 kali 2 4, 4 kali 2 8. So second shell here, maximum number of electrons. Okay, mungkin dia ada kurang daripada 8, tak ada masalah. Okay, but maximum is 8. 1, 2, 3, 4, 5, 6, 7, and 8. Next shell. Okay, the next shell, alamak, dah bengkok lah. Next shell is shell number 3. Okay, sorry because my hand is not artistic. I hope you can view this. Okay, maximum number of electrons in this shell, how many? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, alright, 16, 17, 18. Okay, so according to this formula, shell number 3, where n equals to 3, you can have a maximum 18 number of electrons. Okay, this is how it works. Okay, the first shell closest to the nucleus has lowest energy level. Each shell is located at different energy level and distinguished by the letter of K, L, M, and so on. Okay, so shell designations is this is the energy level. Apa maksud energy level tadi? Energy level, can anybody tell me what it means by energy level? Apa maksud kalau energy level lagi tinggi, maksudnya apa?
Lagi jauh dengan nukleus.
Yes, correct. Lagi jauh dengan nukleus. So apa efek kalau dia lagi jauh dengan nukleus?
More energy.
More energy, yes, correct. So when an electron is having very high energy, what it means? Apa maksudnya?
Reactive.
Dia active, yes. Meaning dia boleh jump to another energy level, or you can jump to higher energy, and then you can jump from one electron to, one atom to another. Okay, so that is what we are talking about, energy level. Okay, all right, next. Now we look into the atomic number. We will go back to this energy level later on in the later slides. Okay, how does the energy levels affect the electrons operation? The atom and electrons operation in a semiconductor. Okay, atomic number. All elements are arranged in the periodic table of elements in order to, according to their atomic number. Atomic number equals the number of protons in the nucleus, which is the same as number of electrons in the electrically balanced atom. Okay, so this is the periodic table. Biasa tengok periodic table ni. Form 4 mesti, Form 5 mesti ada belajar subjek chemical chemistry. Okay. Yes, ada nak cakap apa tadi? Okay, we are going to go back and forth. Okay, kita pergi depan dan belakang, back to this periodic table later on. Okay, example of a copper atom. What is copper? Okay, tengok this periodic table. Which one is the copper?
Copper.
CO ni ke? Ni apa ni?
CU.
CU Okay.
CU lah.
Relax, jangan gaduh-gaduh. CU is the copper So copper atom number 29. Okay, let's go back. 29, okay? So okay, the atom number is 29. So, okay. Shell, okay. Can you draw a shell for this copper atom? How to share it? How to draw the shell? Macam mana? 29 tu nak letak kat mana? Right. So we have a nucleus and ada tak nucleus keluar? Tak keluar nucleus Okay, so the first shell ada dua. So let me draw the nucleus here lah. Okay, so the first shell kita ada dua atom. Second shell we have 8 atom. So total ada berapa dah ni? Kita ada 10. Total kita ada 29 So balance ada berapa? Ada lagi 19. 19 nak letak kat mana? Next shell maximum berapa?
18.
18. Okay, so we can put 18 for the next shell. So balance ada tinggal berapa? Tinggal satu lagi. Okay, so this is 28 So we have another one. Okay. So we have another one, the last one. The 29th electron is in the outermost shell, which is the n equals to berapa ni? N equals to 4 N equals to 1 here, n equals to 2, n equals to 3, and then this one is n equals to 4. So it will be in the valence shell. What is valence shell? What is valence? Outermost. Okay, valence shell maksudnya shell yang paling luar. Alright. Alamak, dah terkeluar pula jawapan dekat situ. Okay, atomic structure for carbon. Carbon, let's look at. I'm not going to go scroll balik Okay, where is carbon? Number apa? Carbon number berapa?
20.
6.
6.
Siapa cakap 20 tadi? Okay, what is this?
No, that one calcium.
Calcium. Yeah.
Calcium.
This one? Betul
Yes.
This is carbon
Yes.
Right. Okay, so how do we draw the structure? We have one nucleus here. And then we have two electrons. So we have when n equals to 1, kita ada 2. When n equals to 2, kita ada berapa electron?
4.
4.
So we have the balanced 4 electrons. Okay. For total we have 6. So that's why the number atom number is 6. Okay. For chlorine, Klorin ada nombor berapa ni? Klorin dekat mana?
CN.
17.
17. So we have chlorine here 17. So how do we draw it? Nucleus. So but as usual we have 2 there, and then we have 8 here. 4, 5, 6, 7, 8. So we have 2 plus 8. Next shell is what?
7.
So we need another 7. So n equals to 3. We have 1, 2, 3, 4, 5, 6, and 7. Okay, so that's for chlorine. Okay, why don't we try one more? Let's take calcium tadi. Can you draw this for calcium? Can you draw it for calcium? Nanti mungkin kita boleh minta seorang tolong ni. Tolong tunjukkan. Can I know Hafiz?
Yes.
Okay. How do we? How's the structure?
2, 8, 8, 2.
Okay. 2. Just go straight. 2, 8, 8, and 2.
8, 2.
So the outermost shell is 2. Valence electron we have 2. So total semua ni adalah 20. Okay. Alright. Let's proceed. Kita tak boleh spend too much time on this. Alright. So the last band. The last band, which is the valence band, is the outermost shell, and valence electron is the electron in the outermost shell. So for calcium tadi, valence electron kita ada 2, valence electron. This valence electron contribute to chemical reactions and bonding, okay, within the structure of a material and determine its electrical properties. Okay, penting valence electron ni. It's very important for you to know what is the valence electron, how many valence electron. Okay, kalau valence electron ada 7 untuk n equals to 2, what does that mean? Kalau valence electron ada 1 for n equals to 3, for example, what does that mean? Okay, it will contribute to different property. Okay, property ni yang penting, ia akan menentukan benda ni jadi positive or negatively charged atom. Okay, kenapa? Why do we have to learn all this? Because all these properties will determine the performance or properties of a semiconductor. Alright. Okay, we can skip this. Just go through quickly. Okay, the question is valence electron. Carbon kita dah buat tadi kan, 2 dengan 4. So the valence electron is 4. Okay, semua dah clear. I hope this one is clear. Okay. Valence atoms. What is valence atoms? It's an atom which has an equal number of electrons and protons. Okay, no electrical charge. Okay, kalau protons is a positively charged, electron is a negatively charged. So kalau balance maknanya number of electrons and proton dia sama. Okay, so for example, this is just any atom. This is, let's say, plus 10. Okay. So electron ada 2 kat sini, and then ada 8. 2, 3, 4, 5, 6, 7, 8. So number of electron here is 10. number of nuclear positively charged proton is also 10. So this is a valence atom. Okay, so valence atom has no electrical charge. They are neither positive or negative. They are electrically or neutral or balanced. The negative charge of electrons will cancel the positive charge of the protons, thus balancing the charge of the atom. This cancellation of charges creates natural attraction or bonding between positive proton and negative electron. Oh. Are you okay?
Bless you, bless you.
Corona.
Ya, kebetulan nak bersin je, you turn on the microphone je. Aduh. Alright, next, ion particles. Okay, what is ion particle? Alright, when an atom loses or gains an electron, an imbalance occurs. Okay, lose or gain an electron, then it becomes imbalance. Atom becomes either positively or negatively charged particle, and we call it ion. So for example, tadi kita ada 2 and 8, right, for a valence. Let's say we have 7 here. 3, 4, 5, 6 and 7. So electron kita ada 7. Proton is what? 8. So what do you think this is? Positive or negative?
Negative.
Any
Negative.
other opinion?
Negative 1.
Yang lain? Ada jawapan lain?
Negatif lah.
Okay, ada yang ada pendapat yang berbeza? Ada yang kata positif? Okay, kalau kita tengok yang positif ada 8, negatif ada 7. What does it mean? Total. Okay, let me leave it to you to think about it. Okay, probably we will find the answer along the way. Okay, but if you can see the logic, you should be able to see whether it's positive or negative. All right, these unbalanced charged ion particles are responsible for electron flow. Okay, electricity. Ions will take or release an electron to become balanced again. Copper atom, it has 1 extra electrons, okay, the valence electron. Okay, copper atom acts as a donor atom. Therefore, the valence electron tends to leave the orbits. Okay, the atoms now have more protons than electrons. Okay, and this creating the atom to be an ion. Cu plus, copper plus. So maksudnya asalnya dia ada electrons kat sini, tapi dia donate to other atoms. So here we have berapa total tadi copper? 2, 8, 10, berapa ni? 18, 19 Asalnya 19. So maknanya yang positif dia adalah ada 19. Electron dia sekarang tadi dia dah donate satu, dia akan jadi berapa? 18 kan? Betul. Okay, electrons dia asalnya ada 1 extra valence electrons. Okay, bila dia donate, apa akan jadi pada copper ion ni? Copper atom ni?
Ini positif.
Dia ada total 1 Jika kita tolak, dia akan jadi plus 1. Plus 1 maksudnya dia sepatutnya dia ada 19. Nukleus dia ada 19, elektron dia asalnya ada 19. But when it donate maksudnya dia dermakan elektron dia dekat atom lain. So copper ni akan jadi satu ion. Okay. Okay, atom asalnya asalnya dia adalah atom, maksudnya dia ada 19 elektron. Okay, termasuk yang Yang sebelum dia donate, we call this atom. After donation, it becomes an ion. So dia donate elektron dia dekat other atom, so it becomes positively charged because dia ada extra photon dalam atom tu. So dia ada extra positive one. So that's why we name it as Cu plus. So plus ni is extra photon. So the atom has more photons than the electrons. So this is creating the atom to become an ion. So from atom it becomes ion. Cu plus. Clear about this? All right. So for example, if we have a positive ion, we have 2 protons and 1 electrons. By right sepatutnya dia ada 2 elektron asalnya kat sini. Tapi dia dah donate keluar, so electrons dia keluar out of this orbit and it becomes only 1 electron. So kat dalam ni ada 2 protons and then only 1 electron, so become positive. Like this one, negative ion, electrons dia ada 3. This we are talking about valence electron. VALENCE. Valence electron. So valence electron kat sini ada 1, tinggal 1, maknanya dia positively charged because of proton dia ada 2. Like this one, proton dia ada 2, elektron dia ada 3 in the electron valence. So maksudnya dia adalah negatively charged. Sebab apa? Sebab dia terlebih 1 elektron. As compared to the proton. Alright. Draw the conversion of chlorine atom to a chlorine ion. Alamak, jawapan dia dah ada kat sini. So chlorine tadi, dia ada dekat valence electron dia ni, ada 1, 2, 3, 4, 5, 6, 7. So kalau dia ada atom lain donate dia 1 elektron, which, let me erase this one. Donate dia 1 elektron. So elektron dia ada berapa? 18. Proton dia ada 17. So dia ada extra elektron. So dia jadi chlorine negatif. Ion. Remember kalau this one is atom, bila dia terima donation extra electrons, it becomes ion. Boleh. So tadi atom, how it becomes ion, this is how it happens. Bila dia menderma elektron ataupun dia menerima elektron, dia akan jadi ion. Sebab dia bukan lagi dalam dia punya natural state. Apa maksud natural state of an atom? Apa maksud natural state of an atom? Atom yang berada dalam keadaan asal dia. Dalam natural dia. Maksudnya, kalau dia asalnya 17 atom, atomic number dalam periodic table itu nombor 17, maksudnya dia ada 17 photons and electrons. Jadi kalau dia menderma ataupun menerima extra elektron, so dia bukan lagi dalam natural state, bukan dalam keadaan asal. bukan dia punya nature. So dia akan jadi ion. Okay, I hope you're clear with that. Alright. Ion charge. A positive ion has one less electron than its proton. A negative ion has one more electron than its protons. Okay, ini semua dah, you dah tahu tadi kita dah mention tadi. Positive ion attracts negative ion to become balanced. This attraction or difference in their properties causes electron flow. Okay. So, ion ni akan menjadikan dia potential untuk menyebabkan berlakunya flow of electrons. Okay, kalau contohnya, kalau tadi dia ada extra, contohnya, how to draw it. I'll just say Cu plus ataupun Cl minus contohnya. Okay, yang ini Cl minus ni maksudnya apa? Dia ada one extra electron. Okay, Cu plus maknanya one extra proton. So, ion ni dia ada tendency ataupun potential to cause electron flow. Okay. So, like this one, plus maknanya elektron dia terlebih. Okay. Dia terlebih elektron, so dia akan menyebabkan ada ruang ataupun potential for the electron to move from its atom to another. Okay, we look into more on this later on. Okay, what is free electrons? Only the free electrons in the outermost shell or valence shell are free to move from one atom to another. This movement is called electron flow. Okay, electron flow. Maksudnya, contohnya kalau ada outermost, the valence shell ada satu electron, it can jump to another atom, and it can jump from this next atom can jump to another atom. So this is what we call the electron flow. These free electrons are loosely held and can easily be moved to another atom or ion. Okay. Because of their distance from nucleus, the electrons have a weak magnetic attraction. So, nucleus kat sini, outermost shell So, outermost shell tak sebenarnya satu je. Kalau atomic number dia besar, so banyaklah shell dia. So, yang paling luar ni, dia punya magnetic attraction dia paling kurang. Okay. Has the least magnetic attraction or the weakest magnetic attraction. So, it's have a tendency for it to jump elsewhere. Okay. Since this attraction is not as strong to the nucleus as the bound electrons in the inner orbits, the electron can move easily from one atom to another. Okay, I have to go faster this time. Okay, so that's the simulation of the free electrons. So this one's from the outermost shell ataupun the valence electron is easily jump to another, another atom. Okay. Now let's look into categories of material. We have conductors, insulators, and semiconductors. Okay. We will look into typical material types, behavior of valence electrons, and typical use. Okay, so this is important. Tadi kita dah recall about valence electrons. We will look into how the electrons in the valence electron we will look into how the valence electrons behave. Alright, for conductors, any material that easily allows electricity to flow. Okay, conductors allow flow of electron. Has 1 to 3 free electrons in the outer ring, also valence electron. Maknanya ada 1 atau hingga 3 free electrons. 1 hingga 3 in the valence orbit. Because atoms with 1 to 3 electrons in the outer ring are held bound loosely to the atom, they can easily move to another atom or make room for more electrons. So yang ada ni 1 hingga ke 3 yang dekat valence shell, it can move easily to another atom. Okay, you can jump easily from, so this electron jumps to this atom, and then the existing here can jump to next to it. Okay. Insulators, yang tadi conductor. So insulator is any material that inhibits or stops the flow of electrons. Any materials with 5 to 8 fluid electrons in the outer ring is considered to be insulator. Okay. They are held tightly to the atom. They cannot easily move to another atom or nor make room for more electrons. Insulator material include glass, rubber and plastic. Okay, so kalau kita tengok dekat valence electron, dia ada 1, 2, 3, 4, 5 and 6. Yang ni susah dia nak jump or receiving any electrons. Okay, bonding. Okay, the types of bonding. In the ionic, we have ionic bond. We have covalent bond. In the ionic bond, one atom transfers to one or more of its electrons to another atom. In a covalent bond, electrons are mutually shared. Okay. Ionic bond, one atom transfers, okay, dia punya electrons dia transfers. Betul ke diagram ni? Ionic bond, covalent. Okay, electrons can be transferred into another atom. Okay, so let's say for example we have silicon atom, and then let's say lah, if you want to the ionic means Si plus ataupun Si minus. So this, when they transfer electron to another, then it becomes ionic bond. But if you have sharing of electron, contohnya, okay, this one is sharing of electrons. By the way, do you understand this diagram? Apa maksud ni? Ada kadang you boleh jumpa like this. Okay, kadang you boleh jumpa 3, 4, 5. Contohnya lah, just choose random atom. So this is the outermost shell of valence electron. Okay, so we represent it with dots here. 1, 2, 3, 4, 5, 6, 7, for example. Okay, 7, carbon is not 7, chlorine or something like that. Just random ni lah, atom number. Okay, not necessarily the carbon. So valence electrons representing by the dots, or we can use this line. Okay, bila dia ada covalent bond. So when this is being shared, so let's say there's another atom, carbon, for example, and then okay, and then dia ada, let's say dia ada 7. So yang ni dia share kat sini supaya dia membentuk satu bonding. So this is what we call covalence bonding. Alright, so they share dia punya electrons. Okay, alright. Let's look into silicon atom. Silicon is the most commonly semiconductor is being used in the electronic industries. Okay, silicon atom shares an electron with each other with its 4 neighbors. Okay, this is effectively creates 8 shares valence electrons for each atom and produces a state of stability. Valence electrons are held tightly together as a result of the bonding. Pure silicon and germanium are poor conductors of electricity. Mana ada gambar dia? Okay. Right, so mana tak ada ni tak ada. Okay, let me redraw it again lah. Silicon and silicon. Silicon berapa valence share dia? Valence shell dia? do we have hold on, give me a second. Nak buka. Okay, can you open up a periodic table? Ya, kalau dekat slide ni saya nak buka banyak, a long way to scroll lah. Can you open a periodic table? Okay, look at the silicon. Okay, in the periodic table, silicon is atom number 14. Okay, so atom number 14, you have 2 electrons, and then you have 2, 3, yeah. Ada 8, 9, 10, and then outer shell dia ada 1, 2, 3, 4. Okay, so silicon outer shell dia ada 4 1, 2, 3, 4 elektron. Okay, boleh follow tak apa yang saya cakap ni? Ini adalah silicon punya atomic structure. Oops. Atomic structure. So dia ada atomic number dia 14. So we have 2 kat sini, and then ada 8 kat sini. 2 plus 8 plus 4. Okay, so dia punya valence electron dia ada 4. So we draw it this way, 1, 2, 3, 4. 4 valence electron untuk typical silicon atom. So if we have 2 silicon atom, okay, so let's say we put it next to each other. So 2, 3, 4. So like this, they tend to share this valence electron. Okay, the most stable atom will have to have like this 1, 2, 3, 4, 5, 6, 7, 8. Okay, dekat outer shell dia tu. Okay, so kalau just one here, and one here. Here we have 1, 2, 3, 4, 5. Ini baru 5. So for a silicon to be stable in nature, it has to have combination or share of electrons. So we have another silicon here, they share kat sini, and then another silicon here, they share kat sini. Oh, sorry. Okay, and then another silicon here, dia akan share kat sini. So yang lain dia maknanya dia single lah, dia tak share. Kalau yang belah dalam, mana yang dia jumpa, dia akan share. So this is how valence electron is sharing, which is with neighbors. So in this case, when it says silicon atom shares an electron with each of its 4 neighbors. 4 neighbors maknanya kita ada, ya. Kita ada satu, 2, 3, 4 neighbor. Okay, 4 neighbors. Okay, any question? Boleh faham tak ni apa saya cerita ni? Jangan saya cakap seorang-seorang dah. Can you understand what I'm saying? Any question?
Yes, sir.
Boleh follow So this is what it means. It's sharing with 4 of its neighbors. So neighbor dia silicon, dekat sini dia akan share lah. So ada sharing punya, sharing of electrons. So as a result of this bonding, pure silicon and germanium are poor conductors of electricity. So disebabkan bonding ni, dia dia kalau you tengok dekat tengah ni dia dah memang stable, dia dah, it doesn't tend to share, donate or receive electron, or it does not tend to move electrons from one atom to another. Sebab apa? Sebab dia dah stable kat situ, very stable because of sharing of the electrons. Okay, yang especially we're talking about this. Okay, dia dah very stable, dia tak, there is no possibility of jumping an electron from one point to another. So if you build the whole, if you build the whole network of atom here, so you have like that, okay, and then ada lagi kat sini, and then you share kat sini. So electrons, if you from here, kalau dia nak jump to here pun dia tak mau terima lagi dah electrons, because dia dah stable kat sini. Okay, and then ini pun dia does not tend to jump, dia tak boleh nak jump. Okay, tak boleh. Why? Because they are stable. They are not, dia susah nak jump electron from one atom to another. Okay, so that creates an insulation, or they are poor conductors of electricity. Okay, any question? So far you dengar silicon atom is what? As a conductor ke, or as a semiconductor ke, ataupun macam mana? Saya nak mari kejap, dekat dah kering. Okay, we have to get moving. Pukul berapa dah ni? Dah lewat ke? Any questions so far? Okay, so like this, electron pair covalent bond. Okay, this is yang, okay, yang sama ada titik ataupun baris macam ni lah tadi, macam saya tunjuk. So this silicon is +4 nucleus, and then electrons dia share dengan dia punya surrounding. Okay, dia share dekat dia punya surrounding. So these are very stable condition. Maksudnya elektron dia dah share, they are very stable condition, so they don't tend to jump electrons. Dia tak boleh nak jump. Susah, bukan tak boleh, susah. So like an insulator lah. Okay, it's hard to jump from one point to another. Okay. Okay, later on we will learn how does the silicon becomes a semiconductor, and cara dia macam mana. Kita introduce something non-silicon here, contohnya carbon. Okay, carbon atom kat sini. So bila kita introduce carbon atom kat sini, dia dah jadi lain, property dia dah berbeza. Okay. Okay, contohnya kat sini kita letak satu lagi carbon atom. Instead of silicon, kita letak carbon atom. So the property is different. Okay, kita meletak, bila kita letakkan carbon atom ataupun any other atoms in between, ada syarat dia lah, bukannya main letak any atom lah. Ada syarat dia kena tengok dia punya number of valence electron. Dia akan menyebabkan the property of the material becomes positively charged or negatively charged. So itu akan menyebabkan electrons easily jump from one atom to another. Okay. Okay, let's look into energy band. What is energy band? Energy band diagram is generally used to represent different energy levels to which the orbiting electrons belong. Okay, the amount of energy that valence electron must attain to be elevated to the next level is measured in electron volts. Okay, so tadi, let's say we have nucleus kat sini, and then we have valence electron. Okay, let's say this is, let's say guna pangkah je lah. Valence electron, and then we have another atom with valence electron, and then we have another atom with valence, one single valence electron. Okay, this valence electron bila dia jump ke sini, and this valence electron jump ke sini, and this valence electron jumps to another atom. Okay, So they will keep on jumping. So electron from another atom jumps into it. Okay, it moves. Okay, this is how the electron move. All right. So to move to another atom, we can measure it in the form of joules. Okay. So this is actually moving from one energy level to another. Okay. So for electron to move, it involves energy. Okay. So the amount of energy is measured in electron volts. Okay, EV, electron volts. Okay, this is the energy band. Okay, let me go back to here. Right. Kalau nampak ni, energy level ni. Kalau atom ni is very close to each other, let me draw it closer. Okay, so for it to jump to the another atom, it has to have another energy. So if we draw this very closely, we can have one something like that. Okay. So let's say I delete the rest of it, this energy level. So you see this electrons is here. Okay. So for it to move to another atom, okay, it has to reach this conduction energy level. Okay. So this is in electron volt dalam bentuk graph. So kalau the energy level dia receive higher than that, then it will go into conduction. Conduction meaning it can jump to one electron to another. Okay, so this is how it works. Okay, right. Following to the next one, because this is how do you understand what is the next thing. So electrons, okay. Remember I mentioned tadi conduction band are easily removed. Okay. Materials that have large number of electrons in the conduction band act as a good conductors of electricity. Alright, so here electrons outermost electrons ni yang paling dekat dengan conduction band, dia senang dia jump. Okay, so for conductor, okay, conduction band dia very close. Okay, for conductor is very close. For insulator, conduction band here is very far. So you nak jump to another electron is difficult. Okay. Conduction bands means refers to energy level, because this is the energy. Remember, we're talking about energy, how much energy the electron has to jump into another atom. Okay, let me redraw that again. So atom electrons here, dia nak jump ni, dia kena ada energy level yang certain energy levels for it to jump. So this energy levels ni, kalau without doing anything, dia level dekat sini. Okay, so in natural state energy level. Okay, so for a conductor, energy level dia very close to its natural state. So electrons can jump easily to from one atom to another. But for a semiconductor, is something in the middle, and for insulator, the energy level is very far. This is energy level in electron volt, ikut graf dia ni. So kalau electron volts, energy level dia lagi tinggi, dia lagi susah dia nak move. Right. Okay, there's a term here, energy gap. Okay, electrons are never found in the forbidden gap or energy gap. Valence band is energy level containing valence electrons. So untuk satu energy level, okay, this is conduction band, this is valence band. So electrons ada dekat valence band ataupun conduction band. So dia nak jump tu, it requires this certain energy level, electron volt. Okay. Valence band is energy level. Okay, this is valence band. Let me write full. Kalau you takut salah faham. This is conduction band. Okay. Next, after this, I will use CB. This one I use VB. Okay, electrons, valence band is an energy level containing valence electrons. Electrons in valence band are more tightly bound to the individual atom than the electrons in the conduction band. Okay. Okay, energy band derived from different material. So, ni yang saya cakap tadi. Insulator macam ni, semiconductor macam ni, conductor macam ni. Okay. So, ini yang masukkan tadi. Conduction band, maksudnya energy to move to from valence band to conduction band tu is intermediate. For insulator, dia susah nak jump into conduction band. Conductor, dia overlap. Okay, it can jump anytime. Okay, valence band ni refers to this. Okay, this is the valence band. Conduction band maknanya bila dia boleh terkeluar energy level yang minimum untuk dia jump to another atom. Okay, so let's say we have another atom here, for example. Okay, so this electron, so this electrons wants to jump to the next atom. Okay, so this, it requires energy. So this is the amount energy is required for insulator. This is the amount of energy required. For semiconductor, this is the amount of energy required. Untuk conductor, very small energy required. Sebab apa? Dia memang boleh jump to next atom easily. Okay, so the difference here is what we call energy gap. Okay, energy gap. So basically kalau kita nak move an electron, one electron from one atom to another, kita nak move from point A to point B, you kena apply voltage kat dia. Okay, you kena apply voltage. Maknanya you kena ambil bateri, you letak dekat material tu, and then sambungkan, complete the circuit. Then that's what it means. So you apply voltage for electron to move from one point A to point B. What is the amount of voltage that you need to apply? It depends. For insulator, this is the how much you need, voltage you need. So voltage here, it's in electron volt, which is very, very small, smaller than the normal voltage. Okay. So for semiconductor, this is the voltage that you require. Conductor, this is the voltage that required. Okay, now let me ask you a question. Why do we call it electron volt instead of volt? Can you open up, book up satu browser and Google what is electron volt? Can someone, Nur Fatihah, can you help me Google and find read the definition of electron volt? Nur Fatihah? Oh, ya? Okay, boleh Google sekejap.
Electron volt, unit of energy commonly used in atomic and nuclear physics, equal energy gained by an electron.
Okay, berapa nilai dia tu dari segi voltage?
The electron volt equals 1.602 darab dengan 10 negative 12. Atau
1.602 times 10 negative
12 joule. 10 negative 12 joule.
Betul? Negative 12?
Joule.
Okay. Joule.
Joule.
So, okay. Ni minus 19 lah. Okay, let's double check the fact later on. Okay, this is the amount of energy required, energy in joule. Okay, later on you go back, this is for everyone, you find out how joules goes to voltage. What is the relationship? What's the relationship between joule and voltage? And why? Okay, this is the question that you need to think. Why we use electron volt instead of voltage? Kan dalam kita punya elektronik kan kita pakai voltage, battery voltage 1.5 volts. Okay, battery AA ataupun battery 9 volts. Okay, so we use voltage. Why here we use electron volts? Can you think why? You rasa kenapa dia panggil electron volt? Anybody? Nur Nadira?
Not sure, sir.
Okay, never mind. Nur Firzana? Rasa-rasa lah. Nur Firzana?
I'm not sure, sir. I'm still search.
Okay, tak apa. Kenapa dia panggil electron volt? Because electron energy is very small unit to measure. Okay, so they introduce this electron volt. Sebab kalau tak, you dalam voltage you kena baca like apa 1.602 times 10 to the minus 20, for example, 1.9 times 10 to the 30 volts. So it's a long susah nak gunakan that yeah. So they introduce one unit, they call it electron volt. Okay, this electron volts, let's say 1 electron volt, 2 electron volt, okay, 3 or whatever the number of electron volts. Okay, so it's a smaller unit than as compared to voltage to represent the energy of the electron. Okay, so you boleh bayangkan macam tu lah, maknanya you bayangkan satu voltage that is required. Okay, it's a voltage that is required for electron to move an electron from one atom to another. Okay, so this conduction band, what is conduction band? Is the energy. Okay, this is energy. We are talking about energy here, energy band. Bukannya, okay, it's not about position, bukan position from point A to point B, tapi the energy that is required to move from point A to point B. What is the number of energy? For example, 20 EV diperlukan, 20 electron volt diperlukan for the electron to move. Depends on the material. So what we want to show here is for an insulator, it's much more difficult to move an electron from point atom A to atom B. Okay, so it's more difficult to move because of why? The gap. Okay, energy gap here is very high. Okay, this is the energy gap. Okay, I have to stop on this slide because sebab banyak lagi ni. I don't know whether I can cover it within today. Sikit lagi untuk part 1. Okay, so let's go into this conduction process. Energy can be added to electrons by applying heat. Okay, so from atom A to atom B, dia punya valence electron here, okay, dia nak move there, and this one will move to somewhere else. When you apply heat, you will be able to help the electron to move. Okay, so tadi kita belajar kita nak apply voltage. Okay, besides voltage, heat can also help for electron to move. Sebab tu electronic components, electronic device is directly affected by the temperature. If it's is the temperature is high, it may have different behavior. Okay, when enough energy is absorbed by the valence electrons, it is possible for them to break some of their covalent bonds. Once the bonds are broken, electrons move to the conduction band, where they are capable of supporting electric currents, okay, electron current flow. The vacancy is left in the atom by missing valence electron is referred to as a hole. The hole is considered to have positive charge because atom is deficient from one electron. So, kalau an atom here, its valence electron jumps outside, disebabkan dia because of the heat, it will create satu hole here. Okay, electron dia dah fly, dah keluar. Okay, dah has flown away because of heat. Now, this atom becomes a hole. A hole means it's positively charged. All right. So this is due to the heat, okay, applied. Okay, that's one of the behavior of the atom. All right. Recombination. Recombination is when a conduction band electron loses energy and falls back into a hole in the valence band. So macam tadi kita apply heat, electron tadi dia akan keluar. So dia will create hole. So bila energy dia the heat is gone, the electron tadi dia akan masuk balik. So this is what we call combination. Okay, hole flow is very similar to electron flow. So tadi maksudnya electron jumps from one atom to another. Okay, but these times kita ada hole. Apa maksud hole? Let's say valence electron maksimum kat sini 8, tapi kita ada 7. Okay. Tadi atom apa yang ada 7 tadi? Valence electron tadi? Yang kita buat example tadi? Ingat tak? Electron apa yang kita buat example ada 7 ni? 7 valence electron. Chlorine, yes. So chlorine ada 7 electron dekat outer shell. 3, 4, 5, 6, 7. Bila 7 bermaksud dia ada kekurangan 1 elektron. Chlorine. So we refer this as a hole. Okay, so the hole moves, considered the movement of the hole from one atom to another. Okay, how the hole moves? Sebab kita tahu electron yang flow kan, how the hole moves? I think I'll have to try to look for a simulation punya video lah. I think that's better explaining. But like electron flows, kalau dia ada one in the valence electron, dia ada 1 elektron, dia akan flow, jump to one another kan. Kalau hole pun sama sebenarnya. Okay, I'll find a video later on, or probably you can look for a video. There is a video on YouTube on the movement of electron and hole. So the flow of the hole or electron ni will create the movement of electricity. Okay, holes move toward negative potential and in opposite direction to that of electron. Okay. Okay, I think we have to stop for now. Tak sempat, tak cukup masa. We'll have to follow through with the next lecture. We will look into the doping process and the type of material and so on. Doping ni maksudnya kita add impurity to the material. Remember tadi kan when I say about silicon, dia ada 4 ni kan. Ada 4 dia, tapi kalau dia ada combine dengan okay, atom silicon lain, so this is what happens. Dia jadi very stable. So doping, bila kita dope, kita remove this, we put another atom kat situ. And this will cause missing or insufficient electron ataupun hole. Okay, it will cause a different behavior. Alright, I think we have to stop for now. It's 11 o'clock already, and we have been here for too long. I'm not sure whether you can still follow ataupun dah your mind have drifted away from somewhere else. Okay, any questions so far?
No.
Okay, we will, if no question, we will continue from part 2 by next week. Which means by right, part 1, part 2 kita cover by today, but it seems like we don't have enough time when we will have to go cover it by next week. Okay, in terms of attendance, because we have 52 students in the group, I assume everyone is attending this session. So I'll just tick on the attendance sheets later on. Okay, so if there's no question, I think that will be all for today. I will see you again next week, right? I will see you again next week in the next lecture. Okay, that's all for today. Thank you very much for your time. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. I'll see you next week. Bye-bye.
Waalaikumsalam.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Alright.
Thank you, sir.
Alright.